Hello students, Ms. Strong here presenting you with the second video for our force and motion unit. We're going to review force and motion and then we are going to talk about unbalanced forces. So a quick review on forces. You should all know that a force is a push or a pull on an object as a result of interacting with another object. So when two objects interact, a force is ultimately exerted on each of them. Some examples of forces are friction, gravity, and air resistance. Alright, so next, a quick review of motion. An object is said to be in motion when its position changes in relation to a point of reference. So let's say if we're looking at this picture here, you'll know that this girl is moving because in relation to, let's say, this point, she's moving away from it. Alright, so we're focused in 8th grade on balanced and unbalanced forces and how they change motion. When we're talking about balanced and unbalanced forces, this involves two things, the size and the direction of the force. In terms of balanced forces, they must be equal in size, they must be moving the opposite direction, and the result is there is no change in motion. So if an object is at rest and balanced forces are acting on it, it's not going to move, it'll stay at rest. If something is moving at a constant speed and balanced forces are acting on it, it will stay moving at a constant speed. Here you have two examples of balanced forces with the elephants moving in the opposite direction, both with a force of 200 newtons, and this box has 10 newtons pushing on it from opposite sides, therefore it's balanced forces. With unbalanced forces, they are unequal in size. The direction of the movement will vary, as in they could be moving opposite directions or two forces moving in the same direction or from two directions that aren't necessarily opposite. But the ultimate result is that there will be a change in motion. These two pictures represent examples of unbalanced forces. Here with this truck, you've got a force of 100 newtons behind it, pushing it forward, versus a smaller force of 60 newtons pushing it backwards. Ultimately, the bigger force is the direction it's going to move in. You also have the guys pushing opposite each other with unbalanced forces and pulling opposite each other with unbalanced forces. But ultimately, you can see that the forces are unequal, therefore they're not balanced. Make sure you get at least one of the examples below for each of the forces. Alright, here's some more information about unbalanced forces. They change the motion of an object in one of two ways. If the object is at rest and an unbalanced force acts on it, the object will move. If the object is moving, then an unbalanced force acts on it. The speed and or direction that the object is moving will change. Well-known balanced forces include what I mentioned before, friction and gravity. Here are the definitions of friction and gravity, but just know that friction and gravity ultimately slow or stop motion. Gravity can actually change the direction of motion as well. And when we're talking about force, we'll also be mentioning net force. That's the combination of all the forces acting on an object. So when the forces are balanced, the net force is going to be 0, and when the forces are unbalanced, the net force is greater than 0. Please keep in mind that if the net force is greater than 0, the object will move in the direction of the greater force. Alright, the last thing that we're going to do in this video is learn how to calculate the net force. In order to do this, all you have to do is find the difference between the opposing forces. So for instance, in this first example, the difference between 2 and 8 is 6, and the direction moving is in the direction of the greater force, which is to the right. If you've got multiple forces acting on one or both sides, make sure you add the total first to get the total. So that's 12, and then find the difference. The difference between 12 and 0 is 12, so it's moving in that direction. For this one, you find the difference. The difference is 0. That means it's balanced. For here, you add each side first, so that's 8. Then find the difference, which is 2, and it's moving in the direction of the greater force. Make sure you watch this as many times as you need to, and if you have any questions, ask your teacher.